Hi guys, this is Dr. Singh here. Today I am going to explore data frames in R. So let us begin. So guys, we have already done the first three part of our overall content in R, that is introduction and data types, vectors and matrix. If you are starting with this data frames, you can also cover up the first three topics that I have given the link in the description. So guys, after this data frame we are going to do list control for statements, function and file processing, apply, dply, etc. So guys, let us start with the data frames. This is what the basic introduction about data frames. Just like matrix, data frame is also two-dimensional representation of data, but in matrix can only have homogeneous type of data, that is the all the data must be of the similar type, but in data frames the data can be of different types in different columns, right? So it gives flexibility to the user to declare various kind of data in the same data object. Fine. So that is what the advantage of it. So in our environment there are actually already available data frames are also there. So for example, state.x77, US personal expenditure, women, and more like this. So this is what the way through create a data frame. So for creating a data frame, just like matrix is basically everything like matrix, data frame or list. Every type of data object use vectors as their basic data. Fine. So for example, here these are the three vectors: days, temp, and rain. These are the three vectors. They are declared like Monday, Tuesday, Wednesday, Thursday, Friday. Another one is the numeric 22.2, 21, and like that. And then rain is the logical one: true, true, false, false, and true. Okay. So how can we create a data frame? Data frame can be created by using inbuilt function data dot frame. Okay, so in this we will put all the vectors like with comma separators, like here days, temp, and rain. Okay, so df is a data frame. This is a variable df is created by using three vectors: days, temp, and rain, like this. So guys, you can create a data frame of having more than three columns as well. So every column will represent a one vector. You can have like this: days, time, rain, weather, forecast, and any n number of vectors can be put as a column in a data frame. So guys, when I will run this or when I print this data frame, I will get the thing like this. So these vectors name will become the column names: days, temp, and rain, and these are populated like this. Days are like this: Monday to Friday, temperature 22 to 25, rain true, true, false, false, and true. Okay, so this is what this structure is, basically the data frame. Okay, so in this you can see that one column is having character data, another column is having numeric data, another column is having logical data. So by column wise you can have different data, but within column you cannot have different data, right? So let us directly begin with the R Studio. So guys, I have already given introduction of R Studio in the very first video. You can firstly check that video as I have given in the description. So guys, just to do it fastly, I have already write some code, so I will just copy that. So firstly we are going to create the data frame. Okay, so see, I have created this n1 vector, c1 vector, and l1 vector. Fine, and I have used for creation of vector. Just I want to repeat that again. For creation of a vector, you need to use the c function, that is known as the combine function. So vector, guys, just to repeat, vector is just nothing, just like an array, as you have used in any other programming language, is a collection of homogeneous data. So this n1 is just like an array consisting of 1 2 3 4 5. Okay, and to create a vector you need to use this c function. Like for data frame you need data frame function, for vector you need c function. So I've created three vectors: numeric type, character type, and logical type. Okay, now I am summing up all these three vectors into one data frame. Okay, so I will use a inbuilt function data frame and n1 comma c1 comma l1, they are being supplied there. So now let us check the output. So guys, check it, n1 c1 and l1, this is how the data is being populated. This is the column number 1, column number 2, column number 3, row number 1, row number 2, row number 3, row number 4. This first column is basically the row number. This is not the data itself. This first row is the column name. It is not the data itself. Data is this much only. Fine. So this is how we can create a data frame. Now let us proceed further. Now let us evaluate some more inbuilt function in it. So there is a head function that works on the data frame. It returns the top 6 rows in the data frame. Tail will return the top 6 from the bottom, and you can also change the head function to display not 6 tuples but more than that 6 or less than 6. So I have put it here too. So let us see. Okay, so because this particular data is having only 5 elements, so top 6 will can only show the 5 one. So bottom 6 also will return in this particular case the 6, all the 5 rows. Top 2 you can see, check now, there will be change, it will only show the first 2. And similarly if I write tail df comma 2, then it will show the last 2, the bottom 2 rows of the uh, data frame. Okay, so this is what we have explored, some more function on it. So let us check one more important function that is known as dim function. Dim will return you the dimension of the data frame. Okay, so let us see. So it is saying that dimension of df is 5 3, that means 5 are the row number and 3 are the column number. Fine. So let us see the indexing. The indexing and selection in data frame. As guys, I have already told you in the previous lectures, in vectors the indexing are start with 1, not like C, C++ or Java indexing is start from 0. Just like that in matrix as well, the indexing is start from 0, from 1, and in data frame also indexing is start from 1. So how can I print the different values, how can I access different values from a data frame? So just like arrays, you need to put it like this, and it is like the combination of rows and columns. Okay, the first represent the rows and the second represent the column. Okay, so I can access it like this, df. When I put it 10, it means I am talking about the first row, and I am putting nothing after comma, it means all column. That means first row all column. That means this is what the first row all column 1 a and 2, all of these 3 will get displayed. Okay, so you can see 1a true is being displayed. Fine. So similarly if I write in a very simplest way comma 1, what does it means? That all rows but only first column. Okay, so you can see what will be the answer. So answer is 1 2 3 4 5, because first column was n1, 1 2 3 4 5, so it is returning 1 2 3 4 5. Similarly if I write 1 comma 1, it means what? I want one element, that means the row number 1 and column number 1 at the, I am asking that element, that is at the row number 1 and column number 1. So here in this case it is 1. So you can see guys, this was our data frame. So this is what our row number 1, this is what our column number 1. So this we are asking. Okay, this is how we can access a specific element. So suppose if I want 1a, I want this 1a and 2b. It means what? I want first and second row and first and second column. So how I can put this? I have to write 1 colon 2 comma 1 colon 2. It means what? First to second column, first to second row and first to second column. Okay, so you'll get it like this. Okay, so let me print this for you again. This was our df. Okay, and this is what we got. 1a and 2b, we got 1a and 2b. Fine. So this is how we do indexing. Now guys, I'm writing something for you and you guess it by yourself. What does it means? I'm taking just a pause. Okay, maybe you have guessed the right. It means that first row and first to third column. That means we are talking about first row and first to third column. That means we are asking for all of these three. Okay, so this is what we got. So if I change it to 1 comma 2, what I will get? I will get only this part, the first row and first and second column, that is this 1 and a only. This is how I can do. So let us move forward. Okay, now let us check for the conditional selection. Okay, let us take the first one. First one, you can understand, in this after comma it is free. That means all columns I want, that is first, second and third, all columns I want, but I want only the rows whose n1 is greater than 1. Okay, so firstly I need to tell what is this dollar sign. Dollar sign is just nothing. Dollar, what it will give? It will give the first column. It is similar to this thing, df dollar n1. Fine. What is the n1? If you remember, n1 is the first column name. Okay, n1 is the first column, so we are talking about the first column. Okay, if I directly write dollar, okay, now dollar, after dollar I need to give the name of the column. The name of the column is n1, and here what I am giving? Index of the column. So index of the column is 1, so that I have given here. Fine. So they are the same thing. We are talking about a column. So what we are saying in this df dollar n1, that means in the n1 column we are selecting the rows which are greater than 1. So that means 2, 3, 4, 5. So these rows we are selecting, second, third, fourth and fifth. But what we are saying, all the columns. So all columns mean we want, if this row we this is greater than 1, so I want all the column of this. This is greater than 1, all the columns of this, all the columns of this, all the columns of this. But this I don't want because it is not greater than 1, it is equals to 1. So you can see the answer. So I am getting 2, 3, 4, 5 and all the columns. Fine. So now I can have the conditional, two condition in the same. So what I am saying now, that n1 is greater than 1 and, let me print, we are saying that n1 is greater than 1. That means we want rows, these 4 rows, but we are also saying that c1 is equals to d. So c1 is equal to d. So we will only get this particular rows, but all the columns is still. Okay, so that is what we are getting. Okay guys, so we have evaluated all ways to have the indexing. Okay, so as we have done the column names and row names in matrix. Similarly, we can do the row names and column names as well in the data frames. So we can have the row names of the data frame, and we can set x1, x2, x3, whatever it is, okay, as the row name. So let me do it for you. So okay, so earlier df was like this, row name or 1 2 3 4 5, it is by default. So I can change that default by using the row names function for df. Okay, so let us see what will be change now. This will be the change, x1, x2, x3, x4, x5. Fine. So this is how we can do the naming. Okay, now let us come to the next part. How we can extend an already existing data frame. For example, here our data frame was this one. So I want n1, c1, l1, n, let's say n2. Okay, here. So I want to add a column here, or I want to x6 as a row. So guys, that is very simple. For that, you need a rbind function. Okay, and then you need to put the values. Okay guys, so let us see rbind, how to add a row. So I have created a new row as x6 here. Okay, and then I have created a vector, because in our data frame first one was the number, second one was the character, third one was the boolean. So I have put the same order 6e and then false. Okay, so this x6 vector is created. Now rbind function requires the name of the data frame and then data that you want to bind with your already existing data frame. So result we will store back with in df, because this says in rbind we mean that already existing data frame is being binded with x6. So we need to put the result back into the data frame. Okay, so let us check what answer we will get. So you can see that another line number 6 is being created here. Fine. So let us move further. Merging in data frame. So guys, those who have already done database must know what is the join. So it is just similar to join basically. So you can see uh, if there are two data frames, this one is the left, this one is the right. Okay, and if we take the intersection, that is known as inner join basically. Okay, fine. So the data, I mean intersection, is basically the inner join. This is the left outer join, it means the intersection plus left, and right outer join is intersection plus right, and then full outer join means intersection plus a tuple plus, I mean left tuples plus right tuple. So what does it mean basically? So let us come back with the R Studio. Okay, so for this we will create another data frame. Okay, so we have created one data frame like this. Another data frame is df2. Now let us print df1. So what does it means basically? So we are creating a data frame with first column named as the customer ID C16. That means 1 2 3 4 5 6 is in sequence. So we have created it like this. Another column is the product. That this function is a repeat function. This will repeat toaster by 3. Similarly, again we are adding another rows, radio by 3. Okay, this radio will repeat by 3. So toaster, 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 radio, radio, radio. Now you can guess correctly what will be the output of this data frame. The first column is having 3 values, 2, 4, 6. Second column is the state. In this, firstly there is the repetition of Alabama. It will get repeated by 2 times, and then OU only 1 time. So you can guess it rightly. What will be it? It will be having 3 rows like this. Customer ID 246, Alabama, Alabama, and OU. Okay, got it. So we are doing merge. Merge is what? Merge is this intersection. Okay, so let us see what will be the output of intersection. So intersection is exactly, so what is the query? Merge. We are merging two data frame on the basis of customer ID. That means customer ID is the common attribute between the two. Okay, so what we have done, customer ID 1 toaster. Okay, then we will see that toaster is there. No, toaster is not there. 2 toast, sorry, 1 toaster, 1 is there. No, 1 is not there. Then 2 toaster. Then we will look here that 2 is the ID in another one. Yes, it is there. So we will get 1, we will get 2 toaster Alabama. Okay, then third ID is not common, fourth ID is common. The 4 radio and Alabama will be there. Similarly, 5 is not there, but 6 is common. Intersection is there with the customer. So this 6 is there. So 6 radio, then OU is there. Okay. So in inner join or in the merge, we are exactly doing the intersection. Now let us do the outer join. Let us do firstly the left outer join. Left outer join is this thing. You want the intersection plus all the tuples of first data frame. Okay. So what we are doing here, we are merging df1 and df2 on the basis of customer, and we are saying all x equals to true. Okay. Yeah, that means the left one. This is the right one. Okay. All x equals to true. That means all the uh, intersect values plus value of x is being added. So you can see one toaster, one was not present in the another one. So it will add all the columns of the first one, 1 toaster, 2 toaster, 3 toaster, 4 toaster, 5, 6. Okay, all the columns of the first data frame is there. Okay, now 1 was not present in the df2. Okay, so it is giving you NA. There is no matching value, that is not applicable. But 2 toaster, that means 2 was here, so it will add Alabama as a state. 3 was not there in the another one, no matching one, so NA. So like this. Okay, this one is what? Your left outer. Similarly, there is a right outer. So I will just do it, do the change here only. So you can guess it right now. What I will do, I will, instead of all x, I will put all y. Okay, so all the columns of y will get displayed. So you can see Alabama OU is there. Okay, and all the matching customer ID is also present in data frame number 1. So 246 was present, 246 is present, so that's why radio and toaster is being written there. Fine, that is what the thing. Now let us see outer join. What was the outer join? In outer join, you are joining or merging df1 and df2 on the basis of customer id, and all is true. All is true means all the columns of first data frame x and all the columns of second data frame will get merged. So you can see all the column of first data frame and all the columns of second data frame is going to merge. Fine. So let us check the last topic in this, looping. So let us see our earlier data frame was this. Okay. So we want to loop in two ways. One way is this, we want to print the rows, and another one is we want to print one of the columns. So how can I do that? So let us do it. So I need to write for I in df dollar and 1. Okay, it means that I in df dollar and 1, it means that I will blame became the element of n1. What I mean to say, that this loop will run for 6 times 1 to 6, that is the size of n1. Okay, and for the first iteration I will become the value of first n1, then second time it will become value of second n1, that is 2, then third time it will become third element, fourth time it will become fourth, fifth time fifth, and sixth time sixth, and it will work like this. Okay, so and then I can print what I. This is how we can do looping column wise. Okay, so you are getting 1 2 3 4 5 6 like that. Okay, similarly, if I want row wise, okay, then how can I print? I will again do I in one column length of df dollar 1, that means the length, I am calculating the length of df dollar and 1. This will return here 6. Okay, so it means I in one column 6, that means this loop will run for 1 2 3 4 5 6. Okay, 1 to 6, this loop will run for 1 2 3 4 5 6. Okay, now what I am putting here, I for the first time I value will be what, 1. Okay, and then we are saying comma 0, it means all the columns of the row 1. Then I will become 2 for the second time, then this will be df2 comma 0, second row all column, then third time third row all column, so like this. So you can see its output. Okay, so 1 2 3 4 5 6 rows got printed. Fine. So guys, I think we have explored all the important facts of data frame. So in the next video we are going to start with this. Thank you. Bye bye. Take care.